Hello. You are watching you are listening to the podcast, and I'm here with my friend Alex,
Hello.
and we are going to be talking about some science stuff. And today's question, and the question of today is, to what extent is seeing believing? Alright, you can go.
So, to start things off, uh, we want to talk about optical illusions.
Yeah,
As you know, this is a fun topic to start about, as it is something that messes with your head.
yeah,
People have different uh, views on it, on optical illusions. Uh, they usually have two meanings, or though it's a standstill picture, it may look like it's moving.
yeah,
You know, the which happen with patterns, or maybe what your brain perceives first. Some people. There's this one optical illusion. It was a man and a woman.
yeah,
Uh, some people might see the man first,
yeah,
and then after taking a harder look, may see the girl.
yeah,
But then it could also be vice versa with other people.
yeah.
So, uh,
That also reminds me of.
there.
Oh, sorry.
Oh no, you go. No, sorry.
So that also reminds me of that one picture that went viral. It's is the dress blue or black, or is the dress white and gold? Everyone is saying, no, it's blue and black. No, it's white and gold. It kind of confused them to think one or the other. Some people saw it as white and gold. Some saw it as blue and black, and that was just really meant to trick people and throw them off.
So, there are different types of optical illusions, and those are paradox illusions, distorting, ambiguous, cognitive, and physiological. Starting with physiological, this happens when your brain sees something and it automatically fills something in that you believe should be there. Cognitive, ambiguous, distorting, and paradox illusions happen your when your brain makes when your brain assumes the information sent by your eyes, and this does correlate with our research question as to what extent is seeing believing.
Yeah.
So moving on to how light and vision works, Josh.
Yeah, I'll take it over from here. So basically, with that being said, we also need to what extent seeing is believing. We also need to learn how we are able to see certain objects and things in our daily lives. So we have things in our bodies. They're called eyes. They're on your. I'm not sure if you heard of them. They're on your face, but they are basically designed to detect the presence of light. So light is an electromagnetic radiation that is emitted from the electrons in an atom. So the color that we see depends on how much energy is being released from the atom's electrons. So basically, a longer wavelength will result in red colored lights, and violet colored lights will have a shorter wavelength. So how I like to memorize this is, Alex, you know how a rainbow looks like? You have red on
Yeah,
top, orange, yellow, green, blue, purple. You notice how how the colors, they get shorter and shorter as they go down on the rainbow?
yeah, yeah.
I like to think
Like
it as red starts off as the one with the longer wavelengths, and purple ends off with the shorter wavelengths. Does it make sense?
oh, yeah,
Yeah.
that makes total sense.
So how an e- so how an electron gains energy is through thermal energy from the sun, light energy, and heat. And there's also many more ways how an electron could gain energy. Those are just some to name the few. So we call the groups of light being released from an atom photons. So if you take a look at an object, they're actually taking a look at a bunch of photons being arranged to look like that object. So if we take a look at that man right over there, you see how he's standing up. See that over here? So now let's say if I like want him to like lay down or something. So see now it's being now like the photons that was being displayed to show him standing up, they now been rearranged to look like he was sitting down. I'm not sure if this demonstration makes sense, but it does to me. We could process that image in our brains is that light will pass, like those photons will pass through the cornea, which is basically a dome shape, which is dome shaped and bends light to help the eye focus. So then the light is entered into the pupil and the iris determines how much light should enter the pupil. It then passes through a lens which focuses light on the retina. When the light reaches these electrical signals, they are sent to the optic nerve, which, goes to the brain and it produces the image that we could see. So human eyes could render 2D images, but they could also process 3D objects. So one way how that helps our eyes process these 3D objects is that they're positioned around like 2 inches apart, so our eyes could see from like different angles and just give us that point of view that lets us see 3D objects. And Alex, with that being said, would you like to talk about color blindness?
Yes, sir. Alright, so, uh, as you know, colorblindness is where you cannot see colors, or uh, colors are very mixed. Um, there are types where, it may be hard to tell the difference between certain colors as they seem the same. And, and another one is where it's uncommon that some people may have a condition where they cannot see colors at all,
Mm-hmm.
and this could they could be very sensitive to light. So how colorblindness works is it's a genetic condition on how the light sensitive cells in the retinas of your eyes react with different wavelengths of light. If you are colorblind, shades of color are different from what you see than a human with normal eyes.
Yes.
You know, this Joshua talked about this earlier. You know,
Yeah.
the rainbow with the waves,
The wavelengths.
and
Yeah.
how he talked about the colors on top tend to have a longer wavelength, whereas the colors on the bottom of the rainbow have a very shorter wavelength. And this happened, and the wavelengths that they show to our eyes, they
Yeah.
differentiate as some eyes see it differently.
Yeah. So that fits with like what I said, seeing is believing, is because even though they see that color, it's like different from reality. So maybe it's like, hey, maybe you shouldn't like of to what extent is seeing believing, because hey, just because you see something doesn't necessarily mean that's what it's supposed to be. You know what I'm saying? And I feel like that could and another thing that to what extent seeing believing like applies to is to me, I see it as something that fits in with this topic is the whole atomic theory, as we were talking about atoms earlier and stuff like that. So now, as you know, we couldn't see atoms until very recently, so that like there's this one guy he was able to I think it was like University of Massachusetts, like some scientist was able to like get a picture of an atom. Even though it's small, it kind of proved its existence, so basically this whole theory started in around 450 BC, where a scientist named Democritus came up with this idea. He basically thought that, hey, if you keep cutting up something into smaller pieces, there would eventually be pieces you couldn't cut. So he named these pieces atomos. So this theory did not get revisited until the 1800s by chemist John Dalton. He believed that everything in this world was made up of atoms, and they were indivisible and indestructible. All atoms of a given element are identical in mass or properties. Compounds are a combination of different atoms, and a chemical reaction is an arrangement of different atoms. He was correct for the most part, but we now know that atoms can be destroyed and divided via a nuclear reaction or something. There's this scientist named it's something smaller, but like there's this guy named Neil Bohr. He wanted to find out how electrons were arranged inside of an atom. So he made like this whole experiment where he used hydrogen gas, and since it only has one proton and one electron, probably you would think that maybe only one color of light will be emitted. But actually, it turns out when he passed energy through a sample of hydrogen gas, it emitted 5 different wavelengths. So this means that that hydrogen electron has 5 different energy levels. And this kind of fits in with seeing is believing, is because, hey, just because you know that something has you see that one thing only has something, but in reality there is like actually like more behind it. You just haven't like discovered it yet. You know? Okay, so I explained this part very poorly, but what I was trying to say is that he did an experiment and he was able to create a model from the results of that experiment and from the evidence from that experiment to create that model, even though he had no idea what the arrangement of the electrons of an atom would look like. All right, and back to the podcast. So, and also what that whole atomic theory goes back to what extent is seeing is believing, is that we didn't really believe it to be true, right? But it makes sense, right, Alex? How everything is made up of smaller objects, and there's eventually pieces you can't, reach,
Yeah, yeah. Just the combinations create different things.
Yeah, and to be fair, it's still a theory. Like, we don't know for certain if it's true or not. We believe it to be true because we see like factual evidence, and I think you could agree with this, Alex, that facts, that one thing that there's, the saying, seeing is believing.
Yeah.
That one thing that can contradict that is, factual evidence. You could talk about that a little bit if you want to.
Like a night
Yeah.
night in a bar where this woman next day claimed something that she saw.
Yeah.
But once people took a look into it, they might have seen the cameras, witnesses,
Yeah.
and they all say the same statement. The cameras saw something different. That's factual evidence.
Yeah.
You could clearly see what's happening in that room.
Yeah.
As maybe what they said could be totally different than what actually happened.
Yeah. Because that reminds me of like one thing. People could like, get away with murder just by that. And vice versa. People could get caught with a crime. People could get away with the crime because let's say you committed a crime, right? And there is no factual evidence to prove that you did it. The judge is not going to believe it. The jury is not going to believe you did it if there's nothing there to prove that you did it, right? But let's say if you did do it, if there was like evidence that shows that you did it, then what they see is like, what they believe. So yeah, so basically I think we're both trying to get at here is just because something happened, right? There's always going to be, just because something happened and we believe the thing that we saw, there could be a deeper meaning. So it's not really best to trust your eyes. It's really best to trust, what facts are presented instead of, just having a bias for what your own eyes saw,
Yeah.
Alex, want to say the final question?
To wrap up this podcast and to conclude, we'll give our answers to the research question. So, to us, we think seeing is not necessarily believing. there are things out there that could trick your brain, see things differently. You know, things like uh, drugs. Uh, if you're tired,
Yeah.
these can affect how you see things and how your mind works.
Yeah.
It could also play with your mind. Um, so there are also illusion conditions like colorblindness.
Yeah.
So even though uh, a two people might see the same picture, they won't see the same colors.
Yeah.
Uh, well, if it makes sense, it's the same as they see and don't see the same picture.
Yeah.
Kind it doesn't really it's really confusing. But
Yeah.
because of this, there are many things that we cannot see that are proven to exist, like what Josh said earlier, the atoms.
Yeah.
That is one example.
So basically, and thank you guys for tuning in to the podcast. Going up to
This is exactly what the heck.
You could